Hey guys, so welcome to the rest of the semester. This is the way we're going to have to do it from now on. This first video is going to be me going over this. I just wanted to touch on it just in case you guys didn't remember. I know he talks about it in his first video, but I don't think he really goes over how to do any of like these examples that he lists here. So, first, let's talk about how we define inverse trig functions and how we get these ranges and where they come from. So, when we're talking about inverse trig functions, we have to know what an inverse is. An inverse is a function that undoes whatever it's an inverse to, its counterpart. So what that means in more mathematical lingo is that if you plug one into the other, they cancel out, and all that you get is 1. So, as an example, ln of x and e to the x are inverses. So if you plug one into the other, they cancel out, and you just get x back. I know, like, it looks like you should get 1, but the function part is now 1. They cancel out. Saying that we get 1 is just a fancy way of saying that they cancel out. Okay. So, the idea for inverses, at least how to determine if we have one, is they have to pass the vertical line test and the horizontal line test. So it's not good enough to just be a function, you have to be a special type of function. So let's look at sine. Sine, we know the graph of it looks like this sinusoidal wave, but it fails the horizontal line test. It passes the vertical one. You draw any vertical line, and it only intersects the graph once, but any horizontal line between -1 and 1 that you draw is going to intersect the graph a bunch of times. So, how do we fix that, and how do we define an inverse? Is we are going to restrict the domain of sine down to just part of it that is that does pass the horizontal and vertical line tests. So what should we restrict it to? Well, in order to get a good idea of sine, we want it to capture all of the possible outputs. So we can go from the maximum output value to the minimum output value. So what we want to do is capture sine on one of these pieces of curve that start at the top and end at the bottom, or maybe start at the bottom, end at the top, depending on which way you're looking at it. But which one do we pick? We could pick from here to here, or from here to here, or from here to here. We're going to choose this one just for simplicity's sake, and because it's what everybody does, because it's the simplest one. It revolves around the origin, so we're going to restrict our graph to just this bit. And this is what we invert. So we have to restrict the domain of sine to -π/2 to π/2. That way, it passes the vertical and horizontal line tests on this little piece, and then we can invert it. Yes, okay. So, what does that mean? Well, let's look at cosine. We're going to do the same thing for cosine. That's what the graph of cosine normally looks like. So again, we want to restrict it to part of it that's just going to go from, that's going to capture the maximum value and the minimum value. So now, for cosine, we're going to go from 0 to pi, because cosine is shifted a little over from sine. And here we can see on this, in this rectangle, in this square, it passes the vertical and horizontal line tests, only intersects once each way. Okay. And then for tangent, this is what the graph of tangent normally looks like, but again, now this is much easier to pick. What do we restrict this to? Well, I'm just going to pick this one. And what are the bounds on this? They are -π/2 to π/2. Okay, so that is where these restrictions are coming from. So in order to talk about sine inverse, our angle theta has to be within negative pi over 2 to pi over 2. And likewise, for if we want to talk about inverse cosine, it has to be between 0 and pi. If we want to talk about inverse tangent, it's got to be between negative pi over 2 and pi over 2. So that's where these things are coming from. I hope that clears that up a little bit. Okay, so now, or here, I don't have to cover that. Let's talk about these examples that he does. I'll just outline these just because I want to go over the unit circle again. So I didn't draw the whole thing on this one, but it's enough for us. So remember this, we have 3 standard angles within the first quadrant aside from 0 and 90 degrees. The first one is pi over 6, the middle one is pi over 4, and the biggest one is pi over 3. And these were their coordinates. I think I've got a video up there about constructing this, so if you don't remember the unit circle super well, you can go back and review that. But remember that the sine of an angle is associated with the y-coordinate, and the cosine of the angle is associated with the x-coordinate. So if we wanted cosine of pi over 6, that would be rad 3 over 2. If we wanted sine of pi over 3, that would be 1/2. That would also be rad 3 over 2. If we want sine, we're looking at the y-coordinate. If we want cosine, we're looking at the x-coordinate. And again, this is in an older video, so if you're a little rusty on that, just go back and check it out there. Okay, so what about that first example? They want sine inverse of 1/2. How do we get to pi over 6? Well, what we're going to do is we're going to look at the unit circle, but we have to ask ourselves this question. Sine of what angle is 1/2? Because here's what's going on. What we do is we don't know what this equals, so we're going to assign it to be theta. We're going to let theta equal sine inverse of 1/2. And this kind of makes sense, because watch, if we took sine of both sides, like if we applied that function to the left side and the right side, we get sine of theta equals, here the sine and the sine inverse cancel out, and we just get 1/2. So answering what is theta is the same as asking sine of some unknown angle equals 1/2. So sine of what angle is 1/2? Okay, so how are we going to do that? We look at our unit circle, and we see that, well, okay, remember sine is like the y-coordinate, so here's our y value of 1/2. What angles have that y-coordinate? That one. Wow, that's not straight. And that one. That is just barely showing up. Okay. Those two angles. But which one is it? Well, remember that sine inverse, in order to talk about sine inverse, our angle has to be between negative pi over 2 and pi over 2. Sine inverse demands that theta be between negative pi over 2 and pi over 2. So that's this half of the unit circle. So that means that our angle has to be this one. And that's what this says here. Since sine of theta is 1/2, or since sine of theta, equals 1/2, that means sine is positive. Then that means theta has to be in quadrant 1, because we were either in quadrant 2 or 1, but this says, well, your only options are quadrants 1 or 4, so we have to say, all right, it's in 1. And then we go back to figure out what the actual number is, we go back to our unit circle and think, okay, 1/2, what angle has a sine value of 1/2? Pi over 6. Okay, I'll have another video with some more examples, but I'm running out of time on this one. So I hope that helped.